guys, I'm gonna try different audio, see how it works. I'm doing this bronze bushing. So you have a facing, OD turning, drill, ID turning, then you have two grooves, inside and outside. Then you have one groove that's outside. You have a oil groove that starts within the first groove and it comes out at the end of the groove. So it actually doesn't start from the face. I had to start it inside of the groove and finish the inside of that second groove. Then also you have a small chamfer and an oil right in the middle of that groove. And then the bushing is being cut off. So you have a lot of features going on. Let's look at the program. I'm gonna try to use a little bit different format. So I'm gonna show you a program, and later I'm gonna try to post like a separate video at home when I have a little bit more time. So I have a facing, and this is only roughing. Okay, the reason why I'm doing only roughing is because my starting and ending points are gonna be different, so I separate them. Same thing as you see over here. Now I have an OD turning, so these are all my tools, dimensions, cutting. Okay, let me see if I can get it closer. And this is also roughing. Next one is the drill. So this is a 310 center drill. Then I have a 930 drill. This is 940, doesn't matter. Actually, what matters is here. Then I have my facing for finish, as you see, only. Now I have an OD turning, only finish. Then I have my bar in, so ID turning, only roughing. Or as you see the plus sign, that means I have a TPC. So my temporary parameters are changed. Okay, and if I'm gonna look here, I think I'm gonna have to be in an edit mode. Set up end. Let me see. So right now, let me see if I can. I thought I can actually look this up. Okay. So what has changed, and your change values are gonna be highlighted in yellow, is safety clearance in. I only use 20,000 retract. Okay, also it's here 20,000 retract, and rough wall relief Z, it's only 20,000. Okay, so let's go back here. So this is my bar turning, my finishing dimension is 1 inch and 1,000. So my final actually dimension is 1 inch and 3,000. So that means I'm gonna do one more finishing pass. This is my groove. So I have one groove, number one pattern, but it says two grooves, and the distance between the two grooves is 2 inches and 4,850. So that's why in one unit I'm gonna do that front and the back groove. This is width of the groove and my finishing and everything. Now the thread in, this is how you do your spirals or oil grooves. Thread in my lead, so the pitch is 2.5 inches. One pass, the height what I changed, because if you go with a lead 2.5 and you go auto, your height is gonna be super crazy deep. And then it's my tooling, the depth of cut, my speeds, and then where I'm starting. So I'm not starting from 1.45 inches, okay? I'm starting from, as far as I remember, it's 60,000 where the groove starts to plus 130. So I'm starting at actually 1 inch, 190,000. But because these spirals, they actually have to accelerate. I calculated the acceleration, so 190 minus 1 inch and 450. This is actually how much it accelerates. The final point Z, it's correct. Then this is that finish part. finishing. So as you see now, it's a 1 inch and 4,000 to 1 inch and 3,000. Got a little taper correction. This is my groove out, so it's my first groove on outside. This is 250, so this is my 1/4 inch center drill and a milling OD. 130,000 drill or milling OD. And then this is my cutoff as a 0, because the pattern 0 is it's all cutoffs, because it doesn't do roughing, it only does finishes. So it's one pass and it's done. So this is gonna be the program. This is the job that I'm doing, and I will link a video of the cycle for the threading, or for cutting the oil groove, as you're gonna see. And like I said, I'll try to stitch up the video for you. Thank you. Hey guys, this video is going to cover actually the unit is gonna be thread in and thread out, but that also covers your spirals and the oil groove. I'm actually excited about this video. The thing is that it's probably gonna take a while to break it down and just clarify, and I think it's gonna be pretty important video. For the fact is that I see a lot of questions about oil groove, especially so I'm a member of a Mazak forum on Facebook, and there's a lot of people asking about help when it comes to programming that. So this is what we're gonna break down. And like I said, the difference between programming a thread is spiral, oil groove, it's all the same. The difference is gonna be between the pitch. So let's break down when it comes to actually threading and the differences. So before we even gonna get down to the actually programming and inputting the information to the machine, like what is thread? And let me see if I can maybe get you closer to the board. Okay, perfect. So technically what the thread is if you have a stock, right, you have a bar. So thread kind of looks like this, right? And the information we need to input into the machine, it's going to be, and actually it looks like, so this technically will be spiral, but normally when you look at the profile of the part, if this is outside, you're gonna see these, you're gonna see threads, obviously. So what's important? So for example, the size of the thread. It doesn't matter if it's 1 inch, 5 inch, whatever, right? Depends on the stock. So for example, if you have to keep it simple, 1 inch stock, this will be your 1 inch. So your starting point on your axe is gonna be 1 inch. And your finish, obviously, if it's a straight thread, it's also going to be 1 inch. If your machine cuts the taper, let's say if it pulls a taper of 5,000, it depends which direction, then you can adjust accordingly, right? So if let's say if your machine cuts a little bit too high in the front and then it holds the size till the end by 5,000, then the beginning of the thread will be 995. And so technically it would, eventually once you get a measure, you got a pretty cut straight. So you have to compensate for the taper. Now, if you're gonna look at like the differences, how we call out the threads on OD and ID, is that on outside, the thread size you put is the top, okay? So if you have a 1 inch stock, we care about this diameter right here, the high diameter. So this is gonna be 1 inch, right? But when it comes to inside, okay, so let's clean this up. And on inside, if you need a 1 inch thread, it's not gonna be the actually bore or the ID size. It's also the top. This should be at 1 inch. So that means the actually ID should be smaller. So remember, when you program your threads, it's always the top that counts, not the bottom, okay? The bottom is the depth. Now, if you're gonna look at, so to kind of, let's say, make it more simpler, is that, and we already talked about, like, so Let's call you have a thread that's gonna be 1 inch, okay? 1 inch by 8. So that means your diameter of the thread, right, it's gonna be 1 inch right here, and it's gonna have 8 threads, 4, 5, 6, 7, 8 per 1 inch of the length. So first one is gonna be your diameter, and second number is gonna be how many of these threads you're gonna have per 1 inch. So if you got 8, obviously, you're gonna have 8. If you're gonna have 12, that's why you see the thread is starting to be more fine, because now you're gonna have a little bit, more of them. If you got, you know, when you look at the thread 20, that's gonna be even finer. And the finer they usually go, they're gonna be, so let's say, like I said, try to make it clear. So this is, for example, gonna be your 8. And if you would look thread 16, it's actually gonna be like half this, half the diameter. It's gonna be much smaller. It's gonna look like this. And it just gets smaller and smaller and smaller. Same thing in reverse. Like I've done thread number 2, so it actually has, like if you look at 1 inch, it was a massive thread, right? So the actually depth of the thread was 1/4 inch. Normally when you program the thread, and for example, you're gonna go with number 8 thread, and you have like, so technically you're gonna call out your thread in or thread out, right? The chamfer, if it starts with the chamfer or it ends with the chamfer, also has a 45 or 80 degrees. If it's just a regular thread, just put a 0, I always do. Then your lead, so your lead, technically, the one you calculated, is if you have a thread number 8, you take 1 divided by the thread number. So if you're gonna divide 1 divided by thread, it's gonna give you 125,000. Okay, so you put a lead of your thread, which in number 8 we will put 125,000 like stated, the angle of the thread, and I kind of like explained, so the angles in a Mazak work a little bit different, right? Because normally if I remember to kind of lower the load of the cut, you can actually adjust the angles, right? And I've tried to do that on Siemens, and actually my threads came out bad. With the Mazak, the way it does it is like if you have a thread, and I kind of explained this in my previous video, right? And threads usually have a 60-degree angles, unless it's a modified or a different type. I think from what I remember it was like a Withward, which was like a British thread that was like 55. Then you have your buttress. Your buttress kind of looks like this. So it has like no ass, technically, if you wanna, no butt. If you look at your, for example, your Acme threads, right? Your Acme threads looks like this and this and this. All these threads, if they're outside of norm, like normal 60 degrees, when you're gonna machine them, do an angle, okay? What the angle does, it's how your machine will feed these threads, right? So obviously, you know, your part is cutting, and if you have a 0 angle, it's always gonna go down to the center. So it's gonna follow your insert, the insert's geometry. When you start putting angles over here, it's gonna start cutting. It's gonna start, let's say, here and here and here, and it's gonna follow that angle once it gets to the center. Well, if you're gonna do that with buttress, you're actually gonna mess up this angle. Same thing, let's say, for example, with this, it's gonna start cutting in the side. So anything that's outside of a norm, use angle 0, and it's always gonna follow that geometry of the insert. If you have a regular thread, even if it's a matrix thread, or it's gonna be just a regular standard thread, for me, I personally used 50 angle, and that works for me. If you're gonna do your spirals, that we're gonna talk about oil grooves, put that as a 0 as well, right? Because it's not a regular traditional 60-degree, you know. So the angles, like I said, normal. If you're gonna go, for example, if you're gonna use it on Siemens or different controls, technically go with the angle of the thread, which is gonna be your 60. So once you're gonna go with 125, for example, here, right? And then if it's, so just to kind of keep it simple, we're gonna go with the angle 0. So it's gonna follow the geometry. And like I said, it's just gonna go here, deeper, 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 once it gets to the bottom. Now, this is there's a option, it's called multi. What the multi is, it's asking you how many entrances do you have. So there are threads that call for actually, it's like it says double thread, for example, or quadruple thread. And what that does is, if you're gonna look at it, it threads in super, super fast. Because if you actually look at the thread, right, from this point, your machine is gonna enter here, right, and it follows this diameter. If you have a double thread, it's also going to enter here. If you got a, let's say, quadruple thread, it's gonna enter here and here. And more the entrances you have, the actually faster is gonna thread in. The trick about this is that every time you're gonna double your entrances of the thread, okay, what it does, it cuts your lead and your depth and everything to half. So if you have, for example, thread number 8, okay, and you leave everything 125,000 lead, right? You know, and for example, it's gonna calculate the height for you, and we're gonna talk about this in a second. It slashes that in half. So instead of thread number 8, you're gonna end up with thread number 16. So if you double your entrances and it calls for number 8, you have to actually set it like a number 4. So instead of lead 125, then your lead's gonna be what do you call it? So your lead, that lead would be actually a quarter, so it will be 250, right? And so on. So technically, if you have four entrances, you have to pretty much quadruple your 125. So that means your lead will be actually half an inch, and then the machine is going to cut that lead in 4 spaces, and that would end up with 125,000 once you actually cut it. So more entrances you have, then you have to double your half. Same thing is, so when you have a height, or for example 80,000 on a double, you have to call it as 160. And so if you have a quadruple, then it has to be 320, and so on. But to keep it kind of, so this is just like I said, if you have a multiple entrances, or you're gonna see, that's how you actually program that. So I'm guessing that unless you're doing these specialty parts, most of the time, when you're gonna actually, how many, you know, when you're gonna do this multiple entrances, just kind of keep it simple to normal. It's like, well, how many entrances you have? You only have one, right? When it comes to the height, so the Mazak is really, really good when it comes to calculating the heights. It doesn't matter what, you know, what thread, if it's a 1.7 pitch, you know, millimeters, or it's gonna be height. Once you get your lead in, just press on auto. And for example, if you have 125,000, which is a thread number 8, your height's gonna be 80,000. Okay, this is 80,000 per site, right? So it's gonna be 160,000 once you, if you look at the bottoms of on the diameter. Now you have patterns. So technically, patterns, what they do is, like, it's gonna ask you how do you want to, like, how many cuts you want. Do you want it to be like a standard, for example? So if you press 0, that's gonna be a standard, you know. And let's say so it will kind of calculate for you like a recommendation of how many passes you should do on the thread number 8 with the 125 lead, and let's say in 80,000 depth of the actual thread. It does actually pretty good job when it comes to threads. So let's say on number 8 it's gonna recommend 12 passes, right? But depends
On the holding, if it's a long part, you know, diameter and all these things, on average it calls out as a 12 passes, but 14 to 16 passes is usually pretty good. If you have a good strong bar, for example, and you know, like a 1.5 or 2 inches bar, for example, and you got a really good holding, so everything is rigid, you can do actually even like 10 or 8. It really depends, but usually 12, 14 to 16, it's a pretty ideal number. If you press 1, that's actually going to ask you, instead of how many passes, you can do the depth of actual cuts, right? So let's say if you have a thin part, or you have a, you know, a very thin bar. I mean, you could have a, what do you call it? You could have a 1/2 inch bar, or whatever you're trying to make a number 8 thread with it. And it's gonna chatter on these heavier cuts. You can actually put, instead of, what do you call it? You can put like even 2,000, right? So it's gonna take 2 or 3,000 per cut. And that's gonna be, you double the diameter, right? So if you got 2,000, it's gonna take 4,000 off of the diameter, and you can look at the position of the tool. If you're gonna go to the TPC that we talk about, that little kind of, it looks like a pen, and it's, you know, showing you like a way, is that in TPC you're gonna have this value. It says about last cut. Right, so sometimes it can show you the last cut is gonna be 4,000. If you need this cut to be smaller, you can go to TPC and make a, let's say, adjustment to 2,000. So all your cuts are like even, so it doesn't actually take more than you want to on the last pass. Now sometimes you can find yourself, depends on the material, that you want this last cut to be actually nicer because it puts a little bit more load. Once sometimes the tool is actually taking a bigger cut, and you might have a chatter, what it can actually do is it can put enough pressure to actually calm that part down, and you're gonna have a nice, even sometimes nicer finish. Like softer materials, for example, some steel, or your cast irons and stuff like that. Like these materials don't like a small cut. Your finish is gonna look like crap, so they actually want a little bit bigger cut. So you can play with it, like 4,000, 6,000, 8,000 last cut, for example. Also depends, same thing, on your tooling. It depends on the type of inserts you have, your coating and whatnot. But just to kind of keep it simple, like I said, what do you call it? You know, pattern 0, that's gonna be how many passes. Pattern 1 is gonna be the depth of cut that you kind of prefer. Then there's another one, which is that was number 2 from what I remember on the list. These are more like for the thread that I've done, like number 2. And what that does is, for example, you have a 1/4 inch depth, right? So it's 1/2 inch on diameter. That's a pretty big thread, by all means. So what that does, if, for example, imagine this is that big thread of yours right here, okay, and the way that device is that your first cuts are gonna be deeper, right? So because usually you're still not that deep, and then it's gonna continue larger, and then it actually thins out. It's gonna get smaller and smaller and smaller and smaller. So once you're very deep into a part and you have a lot of material, right at the end, the cuts are gonna be like even under 1,000. So your number 2 is when you machining like difficult parts, and it starts with the bigger cuts, right? Because the first cut is you only sinking the insert a little bit, and then it gets smaller and smaller and smaller, like what do you call it, down to the last cut. Same thing is like the last cut can actually be bigger. Let's say now, you know, on the last pass, it's gonna take maybe half a thousand, but your finishing pass is gonna be 2,000, right? Which kind of, you know, so you can go to your TPC and actually, same thing, make adjustments to where your last cut is gonna be smaller than that. So okay, so we covered this. So this is a pattern, this is the depth. So normally the depth of cut you're gonna see with the pattern 0, pattern 1, pattern 0, it's gonna be how many passes, and we talk about passes, right? And then you're gonna pretty much go down to the speed of the thread. As you see on the oil groove that I was cutting, my speed is super low, it's 22. Because at this point, you're not even cutting through the material. You literally are ripping through the material. Like I've done parts that, these oil grooves that had a 1 revolution per 7 inches. That's not cutting. You're literally just tearing through the material. And so pretty much, what do you call it? So this would cover, you know, actually the base of, to kind of explain how you actually program these, right? So normal thread, like I said, so let's kind of figure it out when it comes to actually these little details of threading. When you have a 1-inch thread outside, okay? This is gonna be the bar, and we're doing 1 inch with 8 threads, right? So we're gonna do, so how I program it, and this is gonna be out, okay, out on this one. So output chamfer 0, lead 125, my angle 50, how many entrances? I want 1. My height is gonna be set at 80,000. My pattern, for example, I'm gonna set it to 0. It's gonna show me, instead of depth, it's gonna show me 12 passes, right? I'm gonna change it to 14 passes. And let's say my speed, which is a constant speed, that's gonna be, let's call it 300. And that 300 is later is gonna convert to the actual diameter of the material. Now, my starting point X is gonna be 1 inch. My starting point Z, if this is my 0, I want this to be 0. My final point X, it's a straight bar, also 1 inch. And my final point Z, let's say we're threading down to 5 inches. I want this to be 5 inches, okay? Now you have a different, there's different, when it comes to the chamfer and the angles is, let's say for example, you have a angle 0. So the machine is gonna come down here, right at the 5 inches, it's gonna rotate, and then it's gonna come out. Now, when you change, let's say angle, and you're gonna see a 45 to 65, what it's gonna do is gonna run here, and then instead of doing that rotation, it will jump out, okay? So you sometimes how you see, like when it enters like in a spiral, it doesn't, you know, stay in a circle and then goes in. It is same thing. So these angles are actually how the machine actually jumps out of the thread. And there are some jobs, and usually the way it shows you is it's gonna show you the thread like this, and it shows you thread like that. Okay, so it's like what do you call it? So this is how it would look, instead of coming down here, right, and finishing that thread at the end. So this is where you're gonna adjust angles. Occasionally you're gonna get jobs like that. So that would be pretty much like a standard. Now, because it's 1 inch, it doesn't actually mean that your material has to be 1 inch. We always lower the actually material a little bit. You're gonna have your standards, right? It's gonna show you that the minimum material for 1 inch is gonna be 990, and the maximum is going to be 1 inch. You always want that little bit of clearance. And also, and this is, I don't wanna get like into this like little, you know, nitpicking the type of threads, because it actually makes a difference what kind of insert you use. There are inserts just for number 8 thread, and these inserts gonna look like this. So you're gonna have like, I use Sandvik inserts. I think they're like the best. So Sandvik insert, you know, they call them, they're called them like forming inserts, and I think, and you're gonna have an insert, you're gonna have this radius over here. So for example, if you're gonna have an insert for number 8 thread, your threads are gonna come out really nice, you know, like this. You're gonna have a radius and everything. If you're gonna look at like with under microscope, and they're actually, you know, breaks the sharp edges, right? But if you can imagine, let's say that you have a thread which is number 8 right here. This thread is gonna be pointy right at 1 inch. If you cut the material, if you drop the material 5,000, you actually gonna get rid of the sharp edges, because now the material is, let's say the material was over here. If you're gonna go to 990, for example, same thing is like you even removed a little bit. So if you don't have the sharp edges, what that does is that, let's say, you know, you drop your part or whatever, it's not gonna give you that ding because there is no sharp corners. So by average, I dropped the diameter of the outside diameter by actually anywhere between 5 to 10,000, right? So between 990 and 995. Okay. ID, when it comes to internal, is the same thing. Okay. So let's do an ID. So this is gonna be my hole. Okay. We're doing inside, so ID thread number 1. And like I said, so the hole has to be smaller than the actually, because this is gonna be your bore, right? Let's call this, I don't know if this is, oh, that looks like shit too. I need to work on my drawing skills. That's actually kind of crazy since I'm a tattoo artist, but okay. When it comes to geometry, these shapes. Okay, so this is your part. Let's say it's 2 inches, right, from here to here. This doesn't really matter. And we're supposed to do a 1-inch ID thread, right? So technically, our thread is gonna be here. Now, 1 inch, right? It's not gonna be the bore or the hole, like we stated before. 1 inch is gonna be here at the peak of your threads. So if you have a 1-inch thread and your threads are 80,000 per side, so you need to take 1 inch minus 160,000, right? So that's gonna be 840. So your bore has to be minimum an 840, but this is actually not the case. By standard, your bore or your hole of the actually thread, they are always more open, because if you have a thread gauge that is, for example, 1 inch, right? The OD thread gauge, it would get super tight. So normally I'll even open the ID like 860, for example. So you give it even like 10,000 more, 10,000 more, just more room to kind of breathe, if you will. And these are the things that sometimes you have a thread calculators. You can Google, let's say, diameter, inside diameter for 1-inch thread, and it's gonna show you the average. So it's never gonna be exactly 1 inch minus the depth of the thread. And also remember that unless you have a perfect insert, and perfect insert, that means there's gonna be a radius for specific. If you got a big, too big of a radius and you're doing a small, and you're gonna do a small thread, like your no-go will actually go because you give it a little bit too much room. So open up your ID according to the standards. And for me, like I said, if I don't have a standard, I'm gonna take 1 inch minus the depth of the thread, which is 80,000 times 2, right? Because it's per side. And then I'll remove another, let's say, 10,000 off of each side. So my ideal number, if it's 840, I would open up to 860. So OD, we care about the top, right? And ID, we also care about the top of the thread, not the actual material. So this is the difference. When it comes to the spirals, for example, so spirals are actually, when I was talking about it, they're actually the threads. Now, the spirals, what they actually are, you can have a square spiral, or you can have a radius spiral. And the way you actually make them is you use most of the time, you're gonna use a grooving insert that is a square or is a radius. So if I had a spiral that calls out for 62,000 wide, I'm gonna go and I'm gonna use a 62,000 square insert. If it's going to call for 62,000 radius, for example, right? I'm gonna use a 62,000 radius insert. So that gives me 31,000 of a radius per side. Now, a lot of times you're gonna, let's say you're gonna see that my 62,000 insert, okay, doesn't get that full 60,000, okay. Let's say, unless you would go 62,000, let's say deep, right? But your groove only calls out for 15,000 of depth. So your 15,000 will be here. Okay, so as you see, right, right at the bottom, that little bit, that groove is not gonna be 60,000 full, because you don't actually go with the full depth of that insert till it achieves that, you know, that 62,000 width. So sometimes you might have to adjust that. But also you have to remember, when you have these massive spirals that goes like this, and you insert cuts on the side. So it doesn't cut straight like this, right? Where it just follows the pattern. It's just gonna kind of tear, like imagine it's gonna tear to it. So it's gonna actually open up a little bit more with this side. So that's also very important to remember, that sometimes once you're gonna look, like if you have these spirals, that spiral under the microscope is not gonna look perfect like this. And we're talking about, this has gotta be massive pitch. It's gonna look more like this. You got a perfect radius on one side, and it's gonna look a little bit elliptical on the other one, is because now your insert is literally kind of just ripping through the part, and it's not gonna follow perfectly that geometry of that insert. So this is very, also remember that it's important to remember. Sorry guys, I actually ran out of battery, so I'm gonna have to restart this from and just kind of start explaining when it comes to the actual oil grooves and what they are. So let's say, or spirals, let's say that you have a spiral oil groove, for that matter, and there's gonna be two types, unless it's something a little bit more custom, but on average, right, you're gonna have either a radius or you're gonna have a square. I've also done where there's a taper, straight, and then taper again. So we'll concentrate on oil groove or spiral, for that matter, right? That's gonna have a pitch of 2 inches. And we're gonna do 1 inch in diameter and 4 inches on the length, and this is our 0. So the way you're gonna program it, so it will be programmed, if it's external, as a thread out, chamfer 0, our lead is gonna be 2, angle 0, number of entrances 1, and height is gonna depend on the depth of the actual thread. Now, let's say it's gonna call for 30,000, okay? So we're gonna put 30,000 in a height, and the way this is gonna look is, if you have a pitch number 2, that means you will have 2 rotations and a 4-inch length. So the way you're gonna look at it is, well, if you have a pitch 2, okay, that means in 1 inch, all right, this is gonna be 1 inch, you divide 2 that means you can't put 2 rotations of a pitch 2 in 1 inch. So that means you're only gonna have about a half a rotation. This is 1 rotation, and then 2 inches, you're gonna have 1 full rotation. So in 4 inches, you're actually gonna have like 2 spirals. So that's how that works. Things to consider, okay? When it comes to the depth and when it comes to the actual width of your groove or a spiral, is usually when you have a square, it doesn't matter. It's got straight walls. So if you have a 60,000, for example, it doesn't matter if you go here, 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 there's 60,000 all across that insert, right? But for example, what if you have it calls for 62,000 width, okay, and you have a 62,000 right here, but it only goes 30,000 deep. Well, your 60 gonna be here, so obviously over here it's gonna be a little bit less of that. So sometimes what you have to do is you'll have to make 2 programs to run your spiral or your groove, and then you're gonna have to shift, and then you have to accommodate, let's say, so if you're 20,000 short, you're gonna have to shift your starting position or your offset 20,000 and then rerun it to collect that other 30,000 pretty much to kind of make it, you know, perfectly wide. Also, when you run like these crazy, like I mean, I've ran like lead 7. So when you have an insert, like I said, it's not gonna give you, and it just kind of shears through the whole part. Your groove on one side is gonna look perfectly rounded, and the other side is gonna look like this a little bit elliptical. Is because your insert, right, it runs kind of sideways, so your front is gonna kind of give you a little bit less of a radius. When you think about it, it's because it's literally just shearing through the material, and it's not giving you a full revolution to actually cover this whole insert. Once you're gonna kind of, you know, once you're gonna machine it, it's hard to kind of explain, but pretty much it's like, well, if you have a part over here, and let's say I'm gonna do this perfectly rounded, if you stop this insert and you're gonna do a full revolution, it's gonna give you that perfect insert. But now thinking about it, you're just like shearing through it. So it's pushing that back before it actually gets that full radius, and that's why sometimes, you know, think about it, it's like you're pushing this wall forward, and that's why sometimes these walls might be not perfectly rounded. It's still gonna do it, you know, the purpose a lot of times when it comes to this oil groove is for the oil to actually flow. So it's still gonna be functional, but the bigger the lead, the worse usually that wall is going to be. There's really nothing you can do about it unless you're gonna start EDM inserts to kind of achieve that, you know, perfect kind of radius, right? So, you know, so speed 22, angle 0, 1 inches, whatever the height is gonna be, and technically this is how you're gonna do your outside, right? So, you know, you start with starting position 0, ending position on a Z is gonna be 4 inches. Your starting position on X and finishing point on X is gonna be just like in a thread, which is gonna be 1 inch. When it comes to internal, it's exactly the same thing. So let's say we have, for example, and this is, you have to pay attention to what exactly is gonna be the ID. But let's say that it's calling for the ID to be actually 1 inch, right? So we give this bore 1 inch, and it calls for 30,000 depth. That's pretty simple. Normally, like I said, you know, when we have a 1 inch thread, the thread is gonna, you know, the height that we care for, it's gonna be actually the top. When it comes to these spirals, most of the time you actually get a defined ID, so that's all we care about. And then whatever the depth of the spiral or the oil groove is this is where we are putting over here when it comes to the height of that spiral, right? And what do you call it? So let's say, so we already have a 2-inch pitch. The machine's gonna accelerate. So it's not like a regular thread where you have a small pitch, for example, like, 125. So we got a number 8. It's gonna come down, let's say, to 200, and it's just gonna start cutting, right? The bigger the lead, the more usually the machine accelerates. So if you have a part here, okay, so this is our bore, and it calls for the spiral like 2 inches. So let's say it's gonna accelerate from half an inch before the part, and it just goes through it, right, till it hits 4 inches, and it just kind of continues that way. So that's fairly pretty easy. And also, what I urge you to kind of make sure is that if you have a 1 inch, and let's say you have a 3/4 bar, okay, 0.750, then with the bar, obviously, if you have a grooving bar, you're gonna have a grooving insert. That insert is gonna stick out. So let's call it that your bar, the diameter is gonna be 850. So that means you have 150,000 clearance. Make sure that this bar, it's not gonna go low enough where you're gonna hit the bottom, okay? So run like a free pass, do it in a single block, right? So it's gonna accelerate single block, it's gonna stop, then press start, go down, look at the number, where is that? Or if you're further away from the part, bring the bar close to the material, and then if you see it clears, it's not a problem. But if you see the bar is going a little bit too low, it might actually bottom out on the bottom of the part. Then go into your TPC and adjust your clearance on ID, and then and pretty much kind of look at toolpath, or if you're gonna trace it, look at the number and kind of get it down to the point where you have enough clearance where it can freely just come in, come out, and you don't damage your part, or you damage your tool, or actually the machine at the worst case. So that would be pretty much like that. Is pretty simple to kind of to program. Now where it gets a little bit harder is if you have a part, okay, and you're not starting your spirals, or you're not starting your grooving from the beginning, but from a certain point. So let's say that we have a 1-inch part, right? Again, the part is 4 inches here, 0 is here, and it asks you for having your grooves and whatnot, and the spiral starts inside of the groove, and you have to finish inside of the second groove by the end. Now this is gonna be a little bit like where I actually play around with the part, and I'll explain how to do it. There's a video that I've made about like how you actually make these grooves, but just to kind of make it simple, let's call that we having 120,000 groove. It's gonna be squared, and from here to here, for example, it's gonna be 200,000. This groove is gonna be, let's call it 130,000. So this would be 330. And then let's say similar to this side, all I would do is 4 inches minus 130. That's gonna be 3 inches and 870, right here. And then if I wanna know details about that one, so let's call it minus 200. So this would be my 300, 670, right? 3 inches, 670. If I'm going to tell the machine, tell the Mazak to have 5,000, because that means it gives me 5,000 clearance on each part over here, right? Because my groover is 120,000. So that means 330. I would go minus 5,000, right? So I got 5,000 on this side and 5,000 on this side. Then my starting position will be 0.325. That would be an ideal, but that's not how that works. And the reason why that doesn't work like that is because, remember, on these big pitches or these big leads, technically what happens is the machine needs it needs space to accelerate. So what I do is this. I'm gonna go, usually what I do is I'm gonna program the machine, let's say, to start the spiral or the oil groove from a 0, okay? And when I start, I go into single block and I follow the points, right? So it's gonna come down, let's say it's gonna come down to 0.5 inches, and then I'm gonna press start again, and then I'll let it run. So I know it needs ½ an inch of acceleration. So the way I would actually program this is I need ½ an inch from a 0. So that means what I would do is take that 1 point, so 325 is the actual number. So I would add that ½ an inch to that 325, okay? So I would program the starting point on a Z as, let's make it a little bit room, as 0.5 plus that 325, which will be that ideal start point. So equals to 825,000. So my starting point on a Z will be that 825. So technically the machine, what it would do, it would come down here, it drop, let's say, 2,000 or 3,000, right below. Depends on the depth of the cut that we want to go, and usually go with 2,000-3,000 if you have like these big pitch, because it literally, like I said, it goes in pretty violently because it has to shear through this through 4 inches in pretty much 1 or 2 rotations, and then it's gonna accelerate, but it always stops over here. So it doesn't need to accelerate past this. So the ending point is actually what you're gonna put in your starting point. The starting point is usually, what the problem is. So if my 3 inches and 870 is end of this groove, I would do minus 5,000, right? To give it 5,000 on this side and 5,000 on this side. So my ending point will be 3 inches and 865. And technically, so that's how you get your perfectly, where it plunges here, gives you that groove, jumps 5,000 before it hits that wall on the groove, comes out, and it does it. So technically, if you have a 30,000 depth, you're doing 2,000 passes, then you have 15 passes and you're pretty much done with the groove. And it works the same thing on ID. So this is what's important. If you're starting from the 0, you have nothing to worry about. Just your starting point set as 0. But if you're starting inside of these grooves and whatnot, this is where that becomes, like I said, where you have to do a little bit of math. Trust me, it's not gonna start from ½ an inch. Sometimes it's gonna be 622, for example, and 8. So then you're gonna take that number that it starts, add to the end of that first groove, and this is how you're gonna program. And like I said, angle is very important, because with an angle, it's always gonna start at 0 angle, always starts at the same point. But if you give it in a certain angle, it's gonna start angling and it's gonna start cutting eventually into this wall of the groove, which you don't want. So your spirals, and this works for outside and also works for the inside. Like I said, the only difference between technically spirals and oil grooves is most of the time the oil grooves are done with a square insert, your spirals are done with a rounded, but they're technically the same, right? It's just geometry of the tool is gonna be a little bit different. Now, when it comes to, and I'm gonna say, like, I do these a lot too, is when I have a part. So, you know, so we got this cylinder part, and then, you know, inside you have this groove. Sometimes you might actually, it calls out, for example, let's say 130,000. Last one I did, I had 130,000 hole that goes through it. So that has to, you have to do it with the live tooling. Sometimes, you know, you have a small groove right here, and sometimes you don't, right? So this is kind of gets a little tricky, where what you do is you have to kind of look from the face. So that will be the face, right? And then you're gonna see that spiral that it's, let's say, going somewhere here at the section where you wanna put that hole. So I go to C connect, okay? So I lock my C position. I bring my drill over here. So I usually use a center drill first, and then I use a drill after that. But you're gonna use the drill. And then you go and manually, you rotate your C, where you once you eyeball it, where that drill is right in the middle, that it looks like it's almost going through that, what do you call it, through that section where that spiral is. It's not an ideal system, but it actually works. So when you eyeball it, okay, set that C. So you go to your setup page, you teach the C that this is the position, and then you go, you know, you program your drilling. So as you program your drilling, technically program it as a C0, and, you know, let's say you're starting, it's gonna be the manual drill, let's say 1 inch, right? Because we have a 1 inch part. And then, you know, your Z position. So if your groove technically is at, you have to calculate the center of the groove. So if you groove, to be kind of like, you know, to make it simple, it's 200,000, right? And the end of the groove is gonna be, let's say, at 2 inches. So technically subtract half of that groove at 1 inch and 900. And this is where you're gonna plunge. So you drill, and then if you're gonna look down on your groove, okay, so let's say this is gonna be a groove. If you look at the profile and you see the hole is not perfectly centered, so sometimes the drill is gonna be, if you have 120,000 and using 125,000, for example, so this will be ideal, right? Where you have a little bit edges on both sides. But sometimes if you see that the hole is kind of next to it, then what you can do is you can go to an offset, and you can either offset plus, for example, 5,000, or what you can do is you can adjust the rotation of the C, right? So you have to adjust it accordingly. So you might have to go, let's say, 1 or 2 degrees minus, or 1 or 2 degrees on the plus side, till you get it perfectly centered. The good thing about this is that once you're gonna program this and it's gonna work perfectly, and you're gonna get a similar job next time, you never have to worry about these things, because your C position and everything are gonna be saved within the program. So next time, all you really have to do is you go in and you just machine the part, and it's always gonna be right there in the middle. So like I said, so this whole thing about pretty much is like this. So most of the time, spirals, grooves, you're gonna use grooving tools. So it's gonna be a grooving shank, right, with an insert for whatever you need, or it's gonna be grooving bar. Okay, you program these tools as a threading tool. So you don't program it as a grooving tool, because the new Mazaks, especially if you are programming your threads, and then you're gonna look for the tool, well, it's not gonna look for the grooving tools, it's gonna look for the threading tools. So all you really have to do is just set them as a threading tool. You pick the tool, and like I said, and then you just program it as a thread. I think I covered most of these things. Hopefully I didn't miss anything, but like I said, it's, you know, the simple starting point, you know, 0 usually, like I said, it's fairly easy once you get into these grooves. And sometimes, like I said, you have to kind of drill a hole in the middle of somewhere at some position. These usually take, like, they don't take a lot, like maybe 2-3 minutes. You can figure it out, and your starting points, like I said, so start far away from the part, or even if you can, then, you know, pull the part out, figure out your starting sets. Obviously, if you already did the groove and you're gonna try to find, you know, the point for the hole, if you're gonna pull the part out, then you're gonna put the part in, that means, you know, you already changed the orientation, so don't do that. But for your starting points, like I said, it doesn't matter till you did a groove, unless you have a feature that's already been milled, and these grooving and these spirals are already there, right? So it's like, so, you know, you have to decide that for yourself. Now I just got a blueprint that actually, there's certain things that you cannot do. So I have it's a spiral, so technically I got a bushing, and the spiral goes like this. It has no groove in the beginning or at the end, and the groove, one side starts here, right, and the second one starts here. This is technically left hand side and right hand side. Usually your spirals and your grooves and your threads are gonna be right hand side. So to do this, you would need actually left hand side and right hand side tools, or you can start one from the beginning, and the left hand side you would actually have to pull from the back to the front. And that's also how, just to kind of explain, when you have a right hand side thread and you only have a right hand side tool, you obviously thread it from the front, right? Because that's how your insert is located. But if you have a left hand side thread and you don't have a left hand side threading tools, if you can, then go from the back to the front, and that what makes it a left hand side. So you just kind of reverse, you know, your starting points. That's gonna also reverse your thread. But the problem is that also the beginning, it looks like this. So it starts very small and then it goes to the full, right? So there's no spiral. And if you're gonna do this, you're gonna see that sometimes the Mazak's gonna come in, right? It's gonna come in, it's gonna plunge into that groove. It might do 1 or 2 rotation before it finds the same spot and then go, right? Retract, find same position. So if there's no, so technically for me, the way I kind of see it, there's no way for me to actually do that. Because if I'm gonna, if the Mazak's gonna come in at this point, it might rotate once or twice, and then it's gonna create that groove. So if you have a job like this that doesn't have a grooving, the only way to actually do that, you would have to use a thread mill, because thread mill pretty much will come under an angle. Let's say you can adjust an angle of 45 or 60, and it plunges and then it rotates, right? And it's gonna cut this out. Same thing is you can go from the back and rotate, but this is something you probably might have to develop. You have to populate a G-code program from a CAM program like Mastercam or Gibbs. So this is technically only oil groove that I've seen that at this moment I actually don't see it how it can be done, just for the fact is that how Mazatrol actually operates. If I'll ever find a solution for that, and I'm thinking about it, then I'll make an update to this video. Well, hopefully I covered everything, and like I said, and you know, and help some of you guys when it comes to, you know, learning like how to thread and how to like I said, do spirals with these nuances of like you know, your starting points, especially like I said, if it's inside of the groove. You know, appreciate your time. Thank you for subscribing. Thank you for the comments, like I said, and you know, for liking the videos. And like I said, I'll be more proactive when it comes to responding to the comments. Before I went through the comments, and like I said, what I do is I go usually get an email, I got a comment, and I reply through the email. And when one of the subscribers told me that my channel would do much better if I actually replied to this, to the comments, which I thought, which I did, but I've noticed there's none of them, there's actually no replies, so like I said, I backtracked like about a year and pretty much tried to kind of reply to like everything that I saw at this point. So I'll be more proactive. Like I said, I have some videos when it comes to doing like just flat or two flats on parts. I'm gonna pay a little bit more attention to do like more milling videos. I don't know a hell of a lot when it comes to the milling, but I've been kind of trying to experiment a little bit more, and like even for myself to find what actually works or not, when it comes to, like I said, a lot of flats and haxes and stuff like that, because sometimes you cannot obviously do it from the edge of the face, because your haxer square and whatnot is going to be deeper. Keyways are pretty easy. Like I said, I mean, engraving, that's pretty easy too. And it's same thing as drills, but there's like, you have your valleys and you got your pockets, and there's a lot of these things. I'll probably want to do like a really good video when it comes to thread milling, because so you have a thread milling and then you have your planet cycles, right? And these two will actually different. Like planet cycles are you need a specific thread mill, not regular end mill. I play with it a little bit and I just kind of didn't use it, but I'm gonna try to do that. Thread milling is a really good option when you have these crazy Acme threads and whatnot, or especially if you have issues with the clearances. So there's still a lot of things that I can cover when it comes to the comments. Like for example, using a tailstock. So using a tailstock is a very it's a very simple process, right? I did a video on tailstock automation where you can write a manual code to bring the tailstock in and bring the tailstock, and to send the tailstock back home. But I'll do like a short video. It's very simple, and like technically when you bring a tailstock, it's in manual, and I wasn't sure when it comes to if somebody just needs to know how to bring tailstock manual, right, which is going to be simple because you have one knob, or you have pretty much two buttons to come in or out. So if you have a question about certain things, like, can you please be more specific so I know exactly if I should maybe send you to a link of the video they've already made, or if it's a video that I need to kind of make and maybe just clarify things much better, because I kind of try to clarify things how I see them, but obviously, I've been doing this for 18 years, and maybe there are things that they're easy for me to see because I've been doing it so long, but you guys still have struggle understanding what I'm actually trying to say. I don't know how far to the basics I should start, but I remember my first 3-4 months, they were super hard. But I had some people around me that that are long-term machinists, so if it's something that I didn't know, I could always go and ask somebody, right? And it's not always the case with other people. And I don't have anybody to teach me milling because I'm the only one that actually runs Mazaks and milling. So a lot of things is just you have to you just have to experiment. And I have a friend that I made in Colorado. He kind of helped me to start going when with making sprockets and whatnot, so he was super helpful. And like I said, and I mean, it's good to have a good community, right? And help each other out. Sometimes it sucks because nobody's there, but for me, like I said, sometimes when you see things visually, it just makes you understand a little bit better. That's why I start also posting pictures, because if you send me just like a basic, for example, a program, how to make a hex, right? Then I can figure it out, because all I have to do is I can use that as a format, and then all I'm gonna need to do is just make the adjustments, let's say that, for my size, for example, or if you send me, a program for 4 flats, and let's say I need 5, right? All I have to do is adjust, let's say, my size and adjust the angles, and I already have a program for 4 flats. I'm also gonna try to make a few videos, and I'm gonna have to start like noting this, even basic alarms. For example, you might have a alarm that's gonna say you have a bad rotation, or you have some mistakes at this point, or like milling has a lot of alarms, and it's not as self-explanatory as it is when it comes to the turning. So I'm gonna try to also incorporate this into my videos and make videos just based off alarms, because sometimes, like I said, it takes me 20 minutes or half an hour. I make adjustments and just things don't work, and then I find I'm like, oh, okay, that's why, and so next time I'll know better, right? But even after 18 years, like I said, I still come across certain things that happen, and it's like I've never seen before, and and you just have to put in time, and you try to Google certain things, and sometimes you don't find it. Like I talked to Mazak engineers. I had an alarm. It says like, well, it's not even an alarm. So what that was is, so the second 250 that the company bought, every time I would program something, it would constantly says like, that it's a Mazatrol program. You get like a blue alarm, and it says this is a Mazatrol programming, where I'm like, where is this coming out constantly? And let's say if I would program something, it's like I have to delete that, and then the alarm would be underneath, right? So it doesn't actually show you the alarm, because I constantly, every time I would try to replay or go to toolpath, to check, let's say, transferring and whatnot, I would constantly keep coming out with that. So I talked to the Mazak about it. They couldn't figure out what's going on. I actually Googled it, and somebody mentioned that if you have a EIA monitor, so when you have your screen, I know this is not a spiral, but it's one of those nuances that it's kind of a pain in the butt, right? So you have your main screen, and you have your 4 panels, right? 4 sections. So this is gonna be your positions and whatnot. For example, these are gonna be your, your loads and other things. So there was an EIA monitor in this square, right? So you have all your lines, and this is usually when you write a program. But even when you go from G-code to just regular Mazatrol, like this module stays still as a G-code program. So because of this page was still on, it was monitoring. So the Mazak would just come out with constant note that this is Mazak program, not a EIA. So once I changed this module, that alarm came out. So Mazak couldn't figure it out. There was a code for it. It was like 469 or 467 or something like that. I forgot. So there's like these little things that are a little bit nuances, where you have to go and do extra things, and this whole point of it's like, well, less things you have to press, the simpler the program is, there's a less chance of making some sort of a mistake. So I'm trying to simplify things as much as I can, like I said, because technically, that's the whole point of a job, where it's just much easier to review, change, and all these things. Okay, so I'm finished with my rant. Thank you, like I said, for staying with me till the end, if you did. I know it's a long video, and you guys have any comments, anything different I could have done, please tell me. Like, hopefully you like this format, which is half the shop, some pictures, videos, and like I said, and doing a little bit of work on the blackboard. I actually do spend a lot of time trying to kind of think about the the content, and then just throwing all these videos, stitching them up, adding music and all these things. They're actually pretty time consuming as well. But like I said, I actually enjoy doing this, and I enjoy the comments, especially when they're positives. And like I said, and I'll take the negative ones seriously, like into consideration. And like I said, I'll try to improve more and more. All right, guys, thank you, and see you next time.